Namaste, I'm Amin Bosnet. In order to meet the criteria of in-semester assignment of subjects EDST 509 Data Analytics for STEAM educators, me going to present on topic Understanding Descriptive Statistics. Before entering to the topic, let's quickly discuss on the term statistics. Statistics is a broad term and it is a branch of mathematics that deals with collecting, organizing, analyzing, interpreting, and presenting data. In simple words, statistics helps make sense of number and information. And the two main branches of statistics are inferential statistics and descriptive statistics. Now, on the topic descriptive statistics, we going to explore. Descriptive statistics is the branch of statistics that summarizes and presents data in a meaningful way, or in short, descriptive statistics helps us understand and explain what the data shows at a glance. Now, as we see our day-to-day activity, numbers surround us every day, but they only start making sense when we know how to analyze them. So, analyzing of data plays a vital role. As a teacher, I use descriptive statistics to understand my classroom performance, my daily routine, and life beyond the school, like making informed decisions with the data. Today, the key tools I'll explore are central tendencies at mean, median, quartiles, and measure of variability, that is standard deviation and variance. When I look at a student's result, my first question is, what's the overall picture? Let's have an interpretation through mean, median, and quartiles. Firstly, we know mean. This mean also here I wanna tell only through the individual series, not in discrete and continuous series. In individual series, just we can calculate mean simply by sum of item by total number of item. If we divide sum of item by total number of item, then we get the mean. In the same way, median. Median is simply middle value when the data are arranged in a sequential order, that is in ascending order and can be arranged in descending order too. And quartiles. Quartiles means values that divide the data set into four equal groups, yeah, like first quartile, second quartile, and third quartiles, where second quartiles we call it median. Now moving to the next slide, let's take an example of the test scores of 10 students of grade 10 of subject mathematics. Here marks 80, 78, 82, 76, 79, 77, 87, 81, 0 and 10. We have here 10 students marks. Now if we see here the marks excluding 0 and 10, these most most marks are most marks are centered. Yeah, most marks are centered. They are not spread. But if we see 0 and 10, then these 0 and 10, they are the marks which are spread more. Now, from here, um, first let's find out the mean. If we find out the with mean with outliers, here the outliers, first of all let's understand, here 0 and 10 are outliers because they are much lower from the rest of the data. Outliers means much higher or much lower from the rest of the data. Here, from the rest of the data, 0 and 10 are much lower from the data set. So we call it outliers here, 0 and 10. Now with outlier, we find mean is 65. And without outlier, here, the mean we find 80. Now what the learning we get is mean is sensitive to extreme values. That is outliers. Mean is sensitive. Now as we move to the next slide, the median we call the middle value. Now, when while calculating median or the middle value, I have arranged the data in the ascending order and I calculate the median as a 78.5. The meaning of 78.5 means half the students scored below 78.5 and half scored above. Means with outliers, median is 78.5, and if we calculate median without outliers, median is 79.5. Now the learning is median is more reliable than mean when extremes exist or when outliers exist. In this case, median is more reliable. Now let's go to the next. Now the quartiles. Quartile means dividing data sets into four groups. Here, quartile first, quartile second, and quartile third. Here, if we see Q1 group scoring below first quartile, that is student needing help here. They are scoring only 0 and 10. That means outliers affected this group. And Q2 and Q3 group scoring above first quartile but below third quartile. Majority in the middle, that is scores 76 to 82. They are consistent performance. And Q4 group, quartile 4 group scoring above third quartile, that is achieving needling enrichment scores 87. They are top performers. So quartiles helps identify different students group for targeted teaching. This is the main theme we have to understand from the quartiles. And the learning we get from here is quartile guide diagnostic evaluation and differentiated teaching. Now let's move to the next slide. Now the variability. Here, variability or measure of dispersion, we also understand is understanding the spread up to where, how much the data spread from the mean, taking reference as a mean. Central tendencies show the typical score, but they don't reveal how scattered the data is. So, for this, standard deviation works out. And this standard deviation shows how far scores usually fall from the mean. And in the same way, standard variance is the average square distance from the mean. And here our main agenda is why variability matters. It tells us if a student's performance is consistent and helps identify if teaching methods works for everyone and reveal whether the class is progressing together. And let's move to the next. Um, we also say variability. The numbers tells the story, that is with outliers and without outliers. With outliers here, we get mean 65, standard deviation after calculation we found from above test scores 30.5, variance 913.5. And here we find that scores are widely scattered and without outliers scores close together. Oh, this scores close together means good. Now, from here, the learning we get with outliers is high standard deviation, that is unpredictable spread. And without outliers, learning is low standard. What we get learning is from here is low standard deviation means consistent performance. That thing we have to know. Now, the practical interpretation is without outliers. Most students score within 3.2 points of the mean 80. This suggests effective consistent teaching for the majority of the students, because the majority of the students they get the marks within the periphery of 80 marks. So the teaching is effective in this class, we can say. Now, here, how these numbers are making sense of numbers in my life. Okay, how the numbers make sense in my life or in the classroom, let's say. Central tendencies help me report typical students' achievement, and variability tells me whether the whole class is progressing together or unevenly. And quartiles guide me in creating differentiated learning groups, as well as it helps me in diagnostic evaluation too. And if we go through the assessment strategy, then use median when outliers exist. The main thing you have to know is that use median when outliers exist. And mm, in teaching decisions, uh, high variability need differentiation, and low variability consistent progress, that we can understand in teaching decisions. From here we can take teaching decisions. Okay, let's move to the next slide. Next slide is about final reflection. Central tendencies are the heart of data. Yeah, they give me the typical story, and variability is data's wings. It shows how far reality can drift from the average. So, together, they turn raw numbers into meaningful insights, whether in classroom or in my routines or in other life decisions. So, from confused by numbers to confident with data, that's the power of descriptive statistics. Thank you.